So we've learned how to bring in a data set, but there's a few things I should mention. So first of all, notice here that I just have the name of the data set. I don't have a full directory path, and that's because this file is actually in my present working directory, which I've designated here. But if that's not the case, if you have a file in some other directory, then you actually have to use the full path. And then remember, if you're copying and pasting the path from like a Windows Explorer, just make sure that you change the slashes so they're forward slashes and not backslashes. Otherwise, R will not know where to look to find the data set that you're looking for. So either put the file in your working directory or make sure you put the full path, else R isn't going to be able to find the data set and won't be able to open it. One other thing, if we kind of zoom out and look at the full R Studio, you can actually bring in new R scripts by just going to File, New File, R Script. So if your session didn't start with an R script, you can actually bring it in later, or you can just open an existing file if you have an R script saved someplace. Okay, so with that in mind, let's move on to look at some further aspects of our program. And so in this portion of the video, we're going to look to see how to make frequency tables in R. Okay, so I'm going to make a frequency distribution for the variable education, which in the GSS data extract that I'm looking at, is the variable is called educ. And so if I'm just going to refer to it, I can give it the name of the data frame that it's located in, the name of the variable, separated by a $sign. Okay, so the first thing I'm going to do is I'm just look at the variable summary using the summary function, and I'm just going to see if there's any missing data. And in R, missing data is treated as so-called NAs for non-applicable. So if I just run that, and then I look at the output, I see here that basically I have a minimum of 0, I have a maximum of 20 years of education. The first quartile is 12 years of education, the mean is 13 years of education, the mean is 13.53 years, and the third quartile is 16 years of education. And two of these values are missing. Okay, so now if I go back to my code, the first thing that I'm going to do is I'm going to have to get rid of the missing values, because if I don't do that, any operation that I run is going to basically only work on the non-missing cases. And if I have any missing cases in the variable itself, R will by default return NA, or just won't work on it. So what I'm going to do is I'm going to create a new object. And the new object that I'm going to create is going to be called education.total. Now, incidentally, when you're naming objects in R, it's legitimate to use periods. That's a naming convention that R will accept. And so I've just basically made this the total of education, because that's an informative name for this object that I'm going to create. And so what this is going to be basically is just the number of values that are non-missing in R. I'm going to use this eventually for the denominator of my calculation of percentages. And the way that this is going to work is that I'm going to use any value of education that's non-missing. And so here the exclamation point refers to not. That's the not operation. And so is NA is basically saying, is this missing? And then the exclamation in front of it says, is this not missing? And so I'm going to take my variable education that's found in the data frame data set, and I'm going to ask R to locate any values that are not missing. And what I'm going to do is I'm going to take a subset of my original data set. Which data set am I working with? Well, it's my data frame data set. That's also called data set. And so I'm going to take a subset in which the cases are non-missing. So that will include every case except the two that R identifies as NA. And I'm going to take the number of rows that are non-missing. And so education total is going to be a count of the number of rows of the subset of my original data set that has non-missing values on education. And so if I run that and I look at my output window, my output window is going to basically show me how many of those cases are going to be non-missing. But I first have to run one more command. And if I go back up here, I'm just going to run the print command. The print command just basically takes something and prints it to the screen. And I run it. Now if I switch to my output window, we can see that I have 1,972 cases that are non-missing for education. So again, I'm going to use that later. I'm going to use that later to calculate percentages for each of the values of education. Okay, so let's go back to our script window. And here I'm going to basically create the different components of a frequency table. And this is going to be showing you how to do it through hard coding. That is, I'm going to actually create different objects for my frequencies, my cumulative frequencies, my percentages, and my cumulative percentages. Okay, so the first thing I'm going to do is I'm going to create an object called educ.freq. And so this would be the frequency distribution of education. And what I'm going to do is I'm going to take my education variable, again, that's in the data frame data set, separated by a $sign. And I'm going to use the table function to create a table of the different values of education. So this is just basically a frequency table, and it's going to be an object that's going to be stored in education.freq. So I'm going to run that first. And once I run that, I can then use that object to create a cumulative distribution. And the way that I'm going to do that is I'm going to use the cumsum function. And so cumsum or cumsum is basically something that will add the values of some array of numbers in a cumulative fashion. So I'm going to use that function on my educ.freq object, and it's going to basically keep a running total, which will create the cumulative distribution. And I'm going to create an object out of that that's going to be called cum.freq. All right, so let's run that as well. And then I'm going to do something very similar to create my percentages. And so basically I'm going to create a new object called perc for percent, which is going to be the table of my values of education in the data frame data set. And each of those are going to be divided by my education total. Remember, the education total includes all of the non-missing cases of education. That's basically just the denominator of a percentage calculation. And I'm going to multiply that by 100 to turn it from a proportion to a percentage. So if I run that, I'll make that object. And then I'm going to use the cumsum function again on my percent object to create a cumulative percent object that I'm going to call cum.perc. So if I run that, I have to make sure I highlight the whole thing when I run it. That will create my final object. Okay, so now what I can do is basically look to see what I've created. And so I'm going to use the print command again to just print the values of education.freq, the cumulative frequency distribution, the percent distribution, and the cumulative percent distribution. And I'm going to use an option with the print command. I'm going to use the digits option. And the digits option basically is going to create a printout with the set number of digits that I specify. So I'm going to have one digit so I don't have like too many values following the decimal point. And I'm also going to use the cbind command. Cbind stands for column binding, and that's just basically going to match up all of the elements across these different objects, column by column. And so they're going to be basically shown in alignment with each other, and that's going to make for a nicer looking table. So if we just kind of highlight that and run it, and then we just switch to our output view. I'm going to zoom into that. So you can see basically we have kind of the makings of a frequency distribution table. So we have every value of education from 0 to 20. We have the frequency, we have the cumulative frequency, the percent, and then the cumulative percent. Okay, so if we just wanted to kind of look at some of these, it looks like the most common one looks like 12 years of education. There's 540 people who have 12 years of education. And the people who have 12 years of education or less make up a little under half of the data set, 43.5% of the distribution. Right? So we can see that people from here to here make up about 43% of the distribution. So you can see the midpoint is at about 13. We can see the range goes from 0 to 20. And then we can see that there are sort of probably more people at sort of the kind of the mid range of education than the low range of education. So as a whole, we don't have a lot of people who have like less than 10 years of education, including 10 years. We tend to have people who have sort of 12, to 16 years of education or so. Okay, so now that we've kind of looked at kind of a rough-looking frequency distribution. Let's think about a way that we can make this look a little bit more pleasing in publication quality. So what we can do basically is install a package called Stargazer. So I'm not going to run this because I've already got this installed, but Stargazer is a package that you should install. And you should just highlight this and run it. And so that R can use the Stargazer package to make a better looking table than the one we've just created, right? And so Stargazer basically is something that in R makes publication quality data sets. And so what I'm going to do is I'm going to just comment this out because I already have Stargazer installed. I don't need to install it again. But I do need to bring the Stargazer package in with the library function. So bringing it in as a new library just means that we can use the Stargazer command in our R session. So we're just going to highlight that and run it. And if we wanted to, we can actually look at the help function for Stargazer, and basically we can just uncomment this. Incidentally, I'm sometimes commenting and uncommenting commands as a way of just not executing them when I don't want to run them when I'm running the entire session. But if you want to look at it, you can. So I could just run this help command. If I hit run, and then if I zoom out into my larger command, notice that this gives me a help file for Stargazer. So if I kind of look through it here, this will tell me how to use the Stargazer command. So I can use actually the help command for any R command that I want to, and I can just follow the documentation to figure out how to use it. Okay, so let me recomment this, and then we'll go back to our zoomed in view. What I'm going to do next is I'm going to create basically a new data frame. And what I'm going to do is I'm going to put together all of these different elements that I've created previously into a new data frame so that I can read them directly into the Stargazer command and make them nicer looking data frame. Okay, so what I'm going to do is I'm going to create a new object, and I'm going to call it stats.list. And it's going to be a data frame. So the data frame function just basically creates a new data frame. And so I have to tell it which new elements are going to populate the data frame. And so I'm going to have 4 elements. The first is going to be my frequency, the next is going to be my cumulative frequency, the next is going to be percent, and the last one's going to be a cumulative percent. And I'm going to make each of these equal to one of the objects that I've already created, right? So the first object that I already created earlier was education freak, right? That's just the table of the different values of education and their frequencies. I'm going to read this in as a matrix, right? So the as matrix command, I can read this in as a matrix because I want only one of the columns of this object, just the values of the frequencies, not the actual numbers themselves. And if I read it as a matrix, it basically gets rid of those. So the next one, the cumulative frequency, I'm going to just read in the object cumulative frequency. This is only one item per each different value of education, so I don't need to bother bringing it as a matrix. And I can do the same thing for the percent. Again, because I used the table function to make it originally, I'm going to have to use the as matrix function to read this in. Notice that all of these are separated by commas, indicating they basically make up different columns of the data frame. And then the final one is going to be my cumulative frequency. That's just going to be the cumulative percent object that I created earlier. Okay, so now that I did that, I'm just going to highlight this and run it. I should have a new object called stats list, and it's going to have 21 observations and 4 variables. So basically my entire data set. And so if I wanted to, I can look at the names of my stat list just to make sure I did that correctly. And so if we switch to our output view, we can see that our stats list has basically 4 different elements in it. The frequencies, the cumulative frequency, the percent, and the cumulative percent. And if we kind of go back here to our script, we can also print the contents of that value. And then if we look at that again, we can just see that it has all the different values for education from 0 to 20, the frequency, the cumulative percent, the percentage, and the cumulative percent. So just like we saw earlier, but the value added for this is that we can read this directly into our Stargazer command. But before I do that, I'm going to create another object called column.names. And this will be the names of the columns that I'm going to use with my Stargazer command. So I can just run that. Unfortunately, I don't think the columns is going to work because it actually doesn't read it unless the summary option is created as true. So we can actually ignore this. Okay, so we'll just go to the Stargazer command itself, and we can see that the Stargazer command has the following sort of syntax. So first, we need to have some kind of an object that it's going to be run on, and that's going to be run on the data frame stats.list. I actually don't want to use summary, which is why this column's name actually won't work. But if I had this set to true instead of false, I could use this. Now, the reason that I'm setting this to false is because I don't actually want summary statistics. I actually want the actual values that are in the data frame. So instead of summarizing the different values, it's just going to print all the values of education, all the frequencies, all the cumulative frequencies, all the percents, and all the cumulative percentages. So I don't want to summarize them. I just want to list them as they are. I'm going to make this a text file. Although there are other options that I'm not going to talk about, like making it a LaTeX file, for example, which tends to have a kind of a nicer format. The other thing I'm going to include as another option, and notice that all the options are basically separated by commas, is some kind of a title. And so I'm going to call this Table 1 Univariate Frequency of Highest Year of School. And then I'm going to put a sort of note at the end of the table. And you can see that the notes here are included as part of what's called a vector. So in R, if you put C parentheses, that indicates you're going to create a vector. And a vector is basically a set of different elements separated by commas. And so this vector will have two elements. The total sample size, which is just a string that says n equals 1,972, the total number of values of education. And I'm just going to have a source as my second item, which is going to be the GSS 2012. And I'm going to have Stargazer use 2 digits to write my note. So I'm not going to have a bunch of additional information that I don't need. It's going to format it in a nice way. And so I can just highlight this, and I can run this. And then if we just switch to our output window, we can see that we have something that looks more like a publication quality table. Now, you probably want to do a little bit more with this. You probably want to cut and paste this and put it into Excel and format it further. But it sort of looks like output you might get from like an SPSS or a SAS or something like that. So it has a fairly good looking format, and at least it's sort of acceptable looking in most cases. Although if you wanted to publish this or put it in a report, you probably have to do some further editing to make it look a little bit nicer. I may at some point do an additional video on how to use LaTeX with this, but that's a little bit more of a complicated topic, and I don't want to get into that right now.